As I've said earlier, things are fuzzy in the subatomic world. So does that mean that we cannot visualize what the quantum world looks like? For now, no. But we can compute for how quantum systems, examples, atom, like a hydrogen or electron or proton behaves. It's called quantum state. And it's just a mathematical description of how a quantum system behaves, but it doesn't describe what the quantum system looks like. So I and H are constants. I is an imaginary number and H bar is the Planck's constant divided by 2 pi. D over dt, this, is the instantaneous change or how fast a variable changes over time. The wave function, on the other hand, is also called a probability amplitude. It isn't any physical, but it tells you the probability of finding a particle in a point of space. It also tells other behaviors such as its probability momentum or energy or spin. The mathematical interpretation of the wave function looks like a wave with its area that goes to zero. So the Hamilton operator on operate on quantum states linked to the kinetic energy and potential energy of the quantum system. So let's go muna dito sa equation na ito. Like I've said earlier, the Hamilton operator, which is denoted by H, operate on quantum states linked to the kinetic energy and potential energy of the quantum system. So the quantum system changes over time depending on the energy of the quantum system. We can see that the time-independent equation means that the total energy doesn't change over time. So Max Born proposed that the square of the wave function, tells us the probability that an electron can be found in a certain spot. Remember the diffraction pattern. The pattern is not the electron itself, but the probability that the electron will arrive at a particular location. So let's go back to the diffraction pattern. So this pattern, is not the electron itself, but the probability that the electron will arrive at a particular location. So this just means na, kumbaga, kapag sobrang maliwanag ito, ibig sabihin lang, ito yung may pinakamataas na probability na pupunta yung electron dito sa part na ito. At kung maunti yung light intensity dito, it just means na less likely yung electron mapupunta dito sa part na ito. So electrons can be considered as a cloud of probability density. Like this one, for the hydrogen probability density. For example, this. The hydrogen atom doesn't exactly look like this because this cloud represents only the probability that the electron can be located in that region. So the wave function is often written in spherical polar coordinate system. Discussing the system is beyond the scope of the discussion, but what we know is that it is a function of radius and two angles. So radius, ito yung radius, and two angles, namely theta and phi. So, ito spherical polar coordinate system, madidiscuss ito sa Math 23. Pero it's beyond the scope of this tutorial video. But all we know is that this diagram shows the graph of a sphere, like this one, formed through the three variables mentioned, namely r, phi, and theta. It contains parameters n, l, and m sub l. N, L, and m sub l. These are what we call quantum numbers, which we will discuss in the next video. The wave function is highly important in determining the shape of the electron cloud in the SPDF orbitals. So later on, pag nag-discuss na tayo ng electron configuration, makikita ninyo na mga quantum numbers ay maaaring magpakita ng shape ng orbital such as the s orbital, the p orbital, the d orbital, and the f orbital. So once na ginamit nyo itong wave function, um, the wave function will help us in knowing the shape of the orbital. For example, kapag ginamit nyo yung wave function, possibly na ma-visualize natin yung shape ng atom or na shape ng orbital, I mean. But again, this is just, this cloud or this shape is just a probability of where the electron could be located. That's all for our discussion. Thank you very much.